Hello students, last application of derivative is maxima and minima. Now y is equal to f of x is real valued continuous and differentiable function. Then we see what is meant by maxima and minima. Now y is equal to f of x is a function. The graph of this function is in this way. Here point C1, point C2, point C3, point C4. Suppose this point is B and this point is A. Now close the interval AB, there are C1, C2, C3, C4. In this point we draw tangent parallel to x-axis. These points are called as the stationary point or extreme point, because in this point we verify the height of this function or y coordinates of that point is maximum, that is f of c1, f of c2, here f of c3 and f of c4. At that point we verify the function is maximum or minima. The local maxima and local minima means these 4 points are including in this function, but always not 4 points are including. There are 2 points. Then out of these 2 points, the function is maximum or minimum at that point. Suppose C1 and C2. Then at C1, the function is maximum. At C2, function is minimum. Such a type of concept, we find the maxima and minima. That means the value of function at that point we find, which is called as the maxima and minima. Now the first is maxima. I draw figure already here. Now consider y is equal to f of x is the curve. C is, that is peak point, its coordinates is c comma f dash of c. We draw tangent at that point is parallel to x-axis, therefore f of c is maximum. We take two neighborhoods c minus h and c plus h. H is a very small but positive. Then the first order derivative test, a function f of x has maximum at x is equal to c if first order derivative is equal to 0, f dash of c. First order derivative means the slope of tangent. This tangent is parallel to x-axis, therefore its value is 0. Slope is equal to 0. First order derivative is equal to 0 is the first condition. Second, now find first order derivative at point c minus h, left hand side of c. Left hand side derivative at point c, if this derivative is positive, then f of x is increasing for value of x is less than c. That means if we take the value of x is less than c, the graph of function is increasing. That means left hand side derivative is positive. F dash of c plus h is less than 0. That means f of x is decreasing for value of x is greater than c. As c increases, then the graph is downward, that is decreases. That means the first order derivative on right hand side is at point c is negative. Then these three conditions are satisfied, and we say that the given function is maximum at point c. Here h is very small, and then we find value of f of c is called as the maxima at that point. Now similarly, the minima. The curve is also same, but graph is different. Y is equal to f of x is a real valued function, upward direction. Now at point C, draw tangent L. Then again take C minus h and C plus h are the neighborhoods of point C. C minus h is less than C. The first order derivative test, a function f of x has minimum at x is equal to C if f dash of C is equal to 0. First condition is same on both because the tangent is parallel to x-axis, its slope is equal to 0, that means derivative at that point is equal to 0. And second test is left hand side derivative is f of x is decreasing if f dash of C minus h is less than 0. That means f of x is decreasing for a value x is less than C. If we take the value of x is less than C, then the graph is decreasing. The function is decreasing. Second condition. And third condition, right hand side derivative is positive. That means right hand side, if we take x, C increases as C plus h, then graph is increases, value of function increases. F dash of C plus is greater than 0 and function is increases. Here h is very small. Now here note, if f dash of C is equal to 0 and f of C plus h and f of C minus h both are positive, or f dash of C is equal to 0, f of C plus h less than 0, f of C minus h less than 0, both are negative, then the given function is neither maximum nor minimum at point C. That is f of C is neither, we take f of C general, f of C at point C neither maximum nor minimum. Such a cases x is equal to C is called as the point of inflection. In this point the function is neither maxima or minima. We take one more example. Y is equal to x cube. Draw the graph of y is equal to x cube. If x is negative, then cube is negative, downward side. X is positive, upward side. First order derivative we take thrice x square. Take point origin at point C, because C is a point like origin, the graph is passing through origin, and its coordinates is 0, 0. The x is equal to, we take C, f dash of 0 is equal to 0. But first condition is satisfied. First order derivative is equal to 0. F dash of 0 minus h is equal to 3 into, in place of x we write 0 minus h bracket square, which is also positive. F dash of 0 plus h, 3 into 0 plus h bracket square, which is also 3h square positive. Therefore x is equal to 0 is called as the point of inflection. At that point the function is not maximum or minimum. Now the second order derivative test. A function f of x has maximum at x is equal to C if first order derivative is equal to 0 and f double dash of C, that is second order derivative at that point, is negative, then function is maximum and its value is f of C. In second order derivative test, first take first order derivative is equal to 0 because the first order derivative means the slope of tangent. The tangent is parallel at that point, in function is maximum or minimum. And second order derivative at that point is negative, then function is maximum, and find the value of maximum f of C. A function f of x has minima at x is equal to C if f dash of C is equal to 0 and f double dash of C is greater than 0. Second order derivative at that point is positive, then we say that the function is minimum at that point and its minimum value is f of C. Step to solve the example. First step, take first order derivative, that is f dash of x. Second step, function is maxima or minima, f dash of x is equal to 0. First order derivative is 0. In both cases, take first order derivative is equal to 0. Solve this equation, we get value of x are called as the stationary point, that is c1, c2 or x1, x2. Take second order derivative f double dash of x. F double dash of c1 is positive or negative. F double dash of c2 is positive or negative. There are two possibilities. Second order derivative at c1 is positive or negative. Second order of derivative at c2 positive or negative. At least one case is satisfied, not both at a time. Then find if first order derivative is positive, second order derivative is positive, the function is minimum at x is equal to c1, and negative, then function is maximum at x is equal to c2. Similarly, if second order derivative at c2 is positive, minimum less than 0, maximum. In this way, we find f of c1 and c2, and last, if f double dash of x is equal to 0, then we cannot conclude the function is maximum or minimum by using second order derivative test is not sufficient if second order derivative is equal to 0. If greater than 0, function is minimum. Less than 0, function is maximum. But is equal to 0, then we cannot say the function is maximized or minimized, or this condition is not satisfied. Then we apply first order derivative test. Otherwise, all examples are solved by second order derivative test. In our examination, the question is asked, find maxima or minima of the given function, not asked by using second order or first order. Second order test is very easy to solve this problem. If second order test does not exist, then find the maxima minima by using the first order derivative. Now we take one example. Here the example is, find local maxima and local minima of f of x is equal to 2x cube minus 21x square plus 36x minus 20. Local maxima, local minima means in given interval the function is maximum and minimum. There are 4 possible points are different, but at that point in given interval there are 1 or 2 points or 3 points. At that point, find maxima minima, which is called as the local maxima or local minima. Now the given function f of x is equal to 2x cube minus 21x square plus 36x minus 20. Differentiate with respect to x. We cannot write here steps. First step is take first order derivative. F dash of x is equal to 6x square minus 42x plus 36. Derivative of constant minus 20 is 0. Now f of x is maximum or minimum. Function is maximum or minimum. F dash of x is equal to 0, which is called as the extreme point, maximum or minimum. Therefore, 6x square minus 42x plus 36 is equal to 0. Dividing both sides by 6, then x square minus 7x plus 6 is equal to 0. Factorize 6 such that its product is 6 and sum is minus 7. This is a simple factor, x minus 6 and x minus 1 is equal to 0. Therefore, x is equal to 6 or x is equal to 1. These are 2 points. These points are called as the stationary point. Stationary point or critical point. Now at x is equal to 6. First find f double dash of x. F double dash of x, the derivative of first order is 6x square minus 42x plus 36. F double dash of x is 12x minus 42. Therefore, f double dash of 6 is equal to 12 into 6 minus 42. 72 minus 42 is equal to 30. We get positive greater than 0. Therefore, f of x is minimum at x is equal to c. Because second order derivative is positive at 6, therefore function is minimum, and find f of 6. In given example, in place of x we substitute 6. 2 into 6 cube minus 21 into 6 bracket square plus 36 minus 20. 2 into 6 cube is 216 minus 21 into 36 minus 3 plus main example is 2x cube. 2 into 6 raised to 3 minus 21 6 square plus 36 into 6 and minus 20 is equal to 2 into 216. 2 into 200, 2 6 12 1 432 minus, take the rough work, that is 36 into 21 36 into 21 756 plus 6 into 36 minus 20. 6 into 36 is plus 216 minus 20. Then it's sum 8 6 2 into 3 4 minus 7 7 6. Now take its subsection. Minus 128. F of 6 is minus 128 is minimum value. Therefore, f of x is minimum at x is equal to 6 and its value is minus 128. Now, case second. Case first we take here. Case first x is equal to 6. Case second x is equal to 1. Then f double dash of x is equal to the derivative, second order derivative, 12x minus 42. F double dash of 1 is equal to 12 minus 42 minus 30 less than 0. Therefore, f of x is maximum at x is equal to 1, not minus 1. Now find f of 1 is equal to the given function. F of x is, first function is 2x cube minus 21x square plus 36x minus 20, right, which is the given function. In place of x we substitute 1 is equal to 2 bracket 1 cube minus 21 bracket 1 square plus 36 bracket 1 minus 20. Therefore, f of 1 is equal to 1 cube is 1, 2 into 1 is 2, minus 21, 1 square is also 1, plus 36 minus 20 is equal to 36 plus 2 is 38 minus 20 plus 21 41 is equal to minus 3. Therefore, f of x is maximum at x is equal to 1 and its value is minus 3. In this way, we solve some problem. In PowerPoint presentation, I solved some complicated words problem to form the functions. In words problem, this function is not given. I form the function first, then I apply this process or this method. We get the maxima and minima. And finally result, given function f of x is maximum at x is equal to 1 and minimum at x is equal to 6. Its values are maximum value is minus 3 and minimum value is minus 128. Okay, in this way the chapter is completed. In this chapter we see application of derivative. First is to find the equation of tangent and normal. Second, rate measure. Third, increasing decreasing function. And fourth is maxima minima. Now next lecture we study the next chapter, that is derivative. Thank you.